Hello everyone. I'm going to take a little bit of time here to introduce you to a program called Notepad++, as pretty much a necessity, I would say. A lot of these we don't have on campus computers because they're open source, and so you have access to them in general. So I would really go out and find something like Notepad++. Particularly, I think I'm going to demonstrate because it has an alt. It has that ability there to kind of pull down column data, which is going to be incredibly important when you're dealing with data in general. But otherwise, it also has an ability to save in all kinds of different languages. So we're going to go ahead and introduce you here within this program to how Ruby, within SketchUp, but Ruby in general deals with matrices or arrays. So it turns out that another word that we probably have not used enough of for list is an array. So an array in Ruby is just a list basically, and so it looks like this. So I'm going to define just so we can demonstrate how the transformation matrix works. In other words, it works. It's a 4 by 4, but you stack it and fill it column by column, kind of like it does in the program. So remember, you put in 1 0 0 0 0 1 0 0 0 0 1 0 0 0 0 0 1. Well, you do that going down the columns instead. And so here's what it looks like programmatically. If I'm going to go ahead, I'm right here at near the bottom of this. I'm going to make a transformation from scratch, and I'm going to point out that in fact SketchUp has all kinds of great transformations. So I'm going to say A equals open close brackets, and it should know at that point in time that that is then a matrix. So now if I say A open 0 close 0 equals 0 point, it should know that that is actually, you've put 0.0 in the first of row A, and I'm going to say the first spot, which is the second spot, equals 0.0, and that first one should have been 1. If I go here, that would be 1. And you go down on the like. Or you could just do this at the beginning. You could go A1. You could just do this. A equals 0, 0, I'm sorry, 1, 0, 0, 0. That's the first column. 0, 1, 0, 0. That's the second column. 0, 0, 1, 0. That's the third column, and 0, 0, 0, 0. And that's the fourth column, and you should have 16 spots. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So you've actually made an array which you can actually then use a program and a statement like this to transform it into an array. So transform it into something called a transformation entity. In all reality, you should be able to stack this up in the matrix and multiply it as well as you would in your calculator. So this notepad, you're going to notice here, has a great ability to kind of, it shows you the carriage return line feeds. It kind of helps a little bit with a lot of these different programs to kind of show, colorize and whatever. So you'll still need either Alice Schreiber's or L. Folson, his help, basically their Ruby helper, but you're going to want to sometimes go ahead and edit in a program like this. And I would just say, whether it's me or whatever, this one came from Mr. Marco as well. We both are using this one, and so once you get some expertise in a house, you just kind of follow up. It is shareware Notepad, and you'll see later we're going to use it very often to edit data in and out of different programs. So in this case, we could go on, and let's say later on we wanted to change this, and we wanted to change maybe this to be a transformation about the z-axis. That means it would be something like this. I could do this. angle equals, and I'm going to say pi over 12, so I think pi slash 12 period. Very often you need in a program like this to give it a point, so it knows it's a it knows it's a decimal and not a integer. I think that's a protected pi. I don't know whether that's the case. And then you could say A0 equals math, and this is an odd construction, math dot cosine A and G, and you could say A5, which would be the second column, first row, equals minus math dot sine of angle. And you could then say and you could do it any way you wanted, A1 equals math dot sine of angle, and A6 equals math dot cosine of angle. And of course these are commands that you're going to want to learn to kind of look up on the web, or not necessarily even look them up, but examine code. And as a rule, there's usually a lot of faster ways to doing things, but at the start here, as you're just learning matrices, you're going to realize that you'll want to actually use a transformation made from something you actually make yourself. So I'm going to hit a pause here, and we'll go and look at finally the command that takes something from an array or a list and puts it into something called a transformation entity in Ruby Sketchup. Alright, now I'm not trying to make programmers of anyone. I'm just trying to make sure that you put that unit circle and transformations, rotations, and how 3D works for soils and for other things. For concrete, when you've got 3D stress distributions, for design, I want to make sure you're putting that deep, because it's not too bad to go 1 0 0 0 0 1 0 0 0 0 1 0 0 0 0 1 and then switch in cosine minus sine, sine cosine in a bunch of different places and shift the last column to X, Y, and Z. It ain't bad, and if you practice it and use this at the same time your knowledge of 15-degree shifts, it should go so deep that it never walks away. What will help a little bit is seeing some fun stuff come out of AutoCAD dumped into SketchUp and run around in circles. And so I've gone and done a search on these three words, SketchUp Ruby API, and I'm out here to Google, and I'm just going to go down. This is just there's all kinds of free Ruby stuff out on the web. I'm going to go to the transformation. I'm going to show you transformations is how we move things around. Remember, we translate, we rotate. And one of the commands is actually to make a transformation is to make it from an array. So in other words, if I take geom and put transformation.new and then give it the array A, it's going to actually make a transformation matrix. And so that's why, you kind of generally print this out or do whatever you're going to do, and then you go through to here and you put that statement in, and hopefully it all works out good and you can rotate things around. Okay, I'm back again, and now I'm going to go ahead and just show you what that statement looks like in here. We won't put it there. We're going to put a return here. We don't need that. So we've taken A and then we shift a little bit, and now we can, at this point, put a statement that says this: A transformation, that's a new to data structure, equals geom, which is a geometry subset or a class, I believe, inside of Ruby. Geom transformation dot new, and then open parentheses and just tell it A. That's all it takes. It knows that A is a and it will go ahead and Make that a transformation, which means later on you can do things like transform entities, make wheels spin, make things go around, make your drill rig spin, whatever you need to do that's going to rotate. And you can then also nest this like you can do in Excel, so that in addition to kind of moving things around, you can rotate things inside of other things. I will point out that Max 3ds in AutoCAD is incredible physics engine. There's lots of physics engines out there which kind of introduce you to some of this mechanics of not only of statics but dynamics, once again as a way to solidify the unit circle that walks around with 1000001000001000001 is multiplied by XYZ over a 1 dummy for as long as you want, and then you shift in to do a rotation, a cosine minus sine, sine cosine, except when you're shifting about the Y, which is called roll, and you switch the sine on the sines. Okay, we'll see flips and a few other scales as we progress through 3D work, but at this point in time you've got a lot of tools, so I would once again recommend downloading SketchUp, probably 8.0 at this point, and then figuring out later on how to get your drawings in from AutoCAD, getting Notepad++, and then getting on SketchUp Sketchy Physics. We'll talk about which one, and for sure Web Console or Alex Schreiber's Web Console, and that just gives you an ability to play around and do some quick drawing and playing around. You might want to explore Lisp, or at very least some of the things that are available out at AutoCAD University this week. So if you haven't signed up for AutoCAD, Students AutoCAD community, I would recommend doing that, and then we'll start looking at little pieces of lists, but I can tell from the web and other places that people have discovered that SketchUp is a preferred engine for design animation. Thanks for listening.